Vacuum deposition is a family of processes used to deposit layers of material atom by atom or molecule by molecule on a solid surface. These processes operate at pressures well below atmospheric pressure. The deposited layers can range from a thickness of 1 atom up to millimeters, forming freestanding structures. Multiple layers of different materials can be used, for example to form optical coatings. When the vapor source is a liquid or solid, the process is called physical vapor deposition. When the source is a chemical vapor precursor, the process is called chemical vapor deposition. The latter has several variants: low-pressure chemical vapor deposition, plasma-enhanced chemical vapor deposition, and plasma-assisted CVD. Often a combination of PVD and CVD processes are used in the same or connected processing chambers. The vacuum environment may serve one or more purposes: reducing the particle density so that the mean free path for collision is long, reducing the particle density of undesirable atoms and molecules, providing a low-pressure plasma environment, providing a means for controlling gas and vapor composition, providing a means for mass flow control into the processing chamber. Condensing particles can be generated in various ways: thermal evaporation, sputtering, cathodic arc vaporization, laser ablation, decomposition of a chemical vapor precursor, chemical vapor deposition. In reactive deposition, the depositing material reacts either with a component of the gaseous environment or with a co-depositing species. A plasma environment aids in activating gaseous species and in decomposition of chemical vapor precursors. The plasma may also be used to provide ions for vaporization by sputtering, or for bombardment of the substrate for sputter cleaning, and for bombardment of the depositing material to densify the structure and tailor properties. Applications: electrical conduction, metallic films, transparent conductive oxides, superconducting films and coatings, semiconductor devices, semiconductor films, electrically insulating films, solar cells, optical films, anti-reflective coatings, optical filters, reflective coatings, mirrors, hot mirrors, tribological coating, hard coatings, erosion-resistant coatings, solid film lubricants, energy conservation and generation, low-emissivity glass coatings, solar-absorbing coatings, mirrors, solar thin-film photovoltaic cells, smart films, magnetic films, magnetic recording, diffusion barrier, gas permeation barriers, vapor permeation barriers, solid-state diffusion barriers, corrosion protection, automotive applications, lamp reflectors and trim applications. A thickness of less than 1 micrometer is generally called a thin film, while a thickness greater than 1 micrometer is called a coating. Bibliography: SVC, 51st Annual Technical Conference Proceedings, SVC Publications, ISSN 0737-5921. Anders, Andre, Handbook of Plasma Immersion Ion Implantation and Deposition, Wiley Interscience, ISBN 0-471-24698-0. Bach, Hans and Dieter Kraus, Thin Films on Glass, Springer Verlag, ISBN 3-540-58597-4. Bernshar, Reuten F. Handbook of Deposition Technologies for Films and Coatings, 2nd edition. Glaser, Hans-Joachim, Large Area Glass Coating, von Arden and Legentechnik GmbH, ISBN 3-00-004953-3. Glocker and I. Shah, Handbook of Thin Film Process Technology, Volume 1 and 2, Institute of Physics, ISBN 0-7503-0833-8. Mahan, John E. Physical vapor deposition of thin films, John Wiley & Sons, ISBN 0-471-33001-9. Matix, Donald M. Handbook of Physical Vapor Deposition Processing, 2nd edition, Elsevier, ISBN 978-0-8155-2037-5. Matix, Donald M. The Foundations of Vacuum Coating Technology. News Publications, ISBN 0-8155-1495-6. Matix, Donald M. and Vivavenna Harwood. Matix, 50 Years of Vacuum Coating Technology and the Growth of the Society of Vacuum Coaters. Society of Vacuum Coaters, ISBN 978-1-878068-27-9. Westwood, William D. Sputter Deposition, ABS Education Committee Book Series, Volume 2, ABS, ISBN 0-7354-01055-5. Woolley, Ronald R. Practical Monitoring and Control of Optical Thin Films, Woolley Optical Consultants, ISBN 978-0-615-13760-5. Woolley, Ronald R. Practical Equipment, Materials, and Processes for Optical Thin Films, Woolley Optical Consultants, ISBN 978-0-615-14397-2.